Hey, ladies and gents, can you believe the end is almost here? I'm sure many of you are rejoicing, even though this may not be quite the end of the school year you had imagined or the beginning of the summer you had imagined. At least the end is near, right? My brain feels like it's fried. I can't imagine when you all feel like as students, knowing what I feel like as a teacher. I give you credit and I give the rest of your teachers credit for bearing through this couple of weeks that we've experienced. But we have a little bit more work to do before we really can call it quits. Only a couple more of these Mrs. P videos. So in your workbook, we're going to begin on page 361. If you want to open up Agile Mind, my courses still underneath Unit 8. This time down arrow next to topic 24, down arrow next to lessons, and we're going to be on lesson 2. So I'm going to get my book. I'm going to open this page up a little bit bigger. You may want your calculator on the side as well. Nothing major in the calculator today. I'm not going to show you any graphing or anything like that, but just you may want it for your basic adding, subtracting, multiplying, and dividing. Hopefully, these boxes look a little familiar. We saw these in the Stain Sharp quite a bit at the beginning of the year. If you remember, the pattern was you needed to find two numbers that multiply. Remember, the word product means multiply. So two numbers that multiply to the number on the top, and two numbers that add, sum means adding, add to the number on the bottom. So your job was typically to figure out what these two side numbers are. So you will notice there are 4 problems right here on my screen. They're the same 4 problems that are in your workbook on page 361. So while I flip over my screen so I can work through them with you, can you see if you can figure out any of these missing numbers? Remember, you need to multiply to the top and you need to add to the number on the bottom. You work on those. I'm going to flip around my screen here. Uh-oh, I have that going. Let me flip around my camera. There we go. Camera on my computer had flipped around. Okay. So, couple of reminders. Like I said, product means multiply. We want to multiply to the number on the top, and we want to add, sum means add to the number on the bottom. So as you can tell, they had 16. We need to multiply to 16. We need to add to 10. They chose 8 and 2 because 8 plus 2 is 10, and 8 times 2 is 16. So let's work through these bottom 4. If you were still working on them, feel free to pause this video, of course, at any time. Do try them yourself. That would be fantastic. So pause if you need to, but otherwise we are going to walk through these 4. Here goes. So we need two numbers that multiply to 20. I'm just going to kind of write some symbols up here to remind myself, and add to 9. Now, some of you may be able to figure out exactly what that is right away. Others of you may struggle. So here's my suggestions. Start with the multiplying. Always, always, always start with the multiplying. And you can always list yourself out factors. So what I'm about to do here on the side is by no means mandatory, but if you're struggling, it's a really good option. So we need to multiply to 20. So I'm going to list out factors of 20. I'm going to list out things that multiply to give me 20, starting with 1. And I'm going to say, what? 1 times what gives me 20? Well, 1 times 20. I'm going to move to 2. 2 times what gives me 20? Well, that's 2 times 10. I ask myself, 3 times what gives me 20? Well, 3 times what? Now, if you're struggling with this one, then remember what the reverse of multiplication is, division. So if I'm struggling, I can always go to my calculator and say, okay, I need 3 times something to get 20. So I'm going to work backwards. 20 divided by 3 is what? Oh, decimals. We don't like decimals. So I'm actually going to cross out the 3 because 3 is not going to work. My next number would be 4. 4 times what gives me 20? And just to show you that this works, again, if you're struggling with 4 times what gives me 20, I'm going to work backwards and do 20 divided by 4. Oh, 5. So that means 4 times 5 gives me 20. This is where your calculator comes into play. So I've now listed out all the pairs of numbers that multiply to 20. How do I know it's all of them? Well, after 4, I would write a 5, but notice that 5's already on my list. That's how I know I've covered everything. If the next number I say is already on my list, I know I've covered everything. So now these are my 3 pairs of factors that multiply to 20. I need a pair that adds to 9. So if you need your calculator, use it. 1 plus 20 is 21. 2 plus 10 is 12. 4 plus 5 is 9. Bingo, my missing numbers are 4 and 5. Okay, notice we have a negative in this case. I want to multiply to negative 15 and I want to add to 2. Now, I have a negative in there. Keep that in mind. I want to multiply to negative 15. Keep in mind that multiplying to a negative means I have 1 positive, 1 negative. So I'm going to run through the same things as we did before. 1 times 1, what gives me 15? Well, 1 times 15. 2 times what gives me 15? Well, that would be a decimal. Not going to use it. 3 times what gives me 15? Well, that's 5. 4 times what gives me 15? Well, that would be a decimal. I'm not going to use it. And 5's already on my list. So I only have 2 pairs that multiply to give me 15. Now, in order to multiply and get a negative, I'm going to have to put 1 negative number in here somewhere. But I'm not going to place that until I think about what's going to add to give me 2. Well, 1 and 15 are too far apart to ever give me 2. But where could I put a negative? I know it's going to be 3 and 5, but the question is, where does that negative go so that I add to 2? Well, negative 3 plus 5 would give me 2, and negative 3 times 5 would give me negative 15. Moving on to the third one, I need to multiply to 12 and I need to add to negative 7. So I'm going to do my list. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And 4 is already on my list. It'd also be my next number, so I know I'm done. Now, I know I need to add to negative 7. Now I know 3 and 4 add to positive 7, but how do I get 2 numbers to add to a negative but multiply to a positive? Well, keep in mind, to multiply to a positive, I either need 2 positives, which I have, but they don't add to a negative, or to multiply to a positive, I need 2 negatives. If I make both the 3 and the 4 negative, 2 negatives multiply to a positive 12, and negative 3 plus negative 4 gives me negative 7. And my last example, multiply to negative 20 and add to 8. So I'm going to list out my numbers. 1 times 20, and actually, look at that. It's going to be the same list of numbers as number 1. We had a 20 over there. Now I realize I'm not even going to write the 3 because I know I'd just cross it off. I realize that this 20 is negative and this 20 is positive. Their list is going to be the same, but now I'm going to play with the negative to figure out how do I get it to multiply to a negative. Well, if I multiply to a negative, one of these numbers is positive, one is negative. But if I need to add to a positive, we just kind of have to play with where that negative goes in order to add to 8. So which of these numbers look like they're 8 apart? Well, that would definitely be 2 and 10. Now, 2 plus 10 is 12. If I did 2 plus negative 10, I get negative 8. I don't want negative 8. I want positive 8. It is my 2 that needs to be negative. Negative 2 times 10 is negative 20, and negative 2 plus 10 is 8. So hopefully you remembered those box problems, or you remember that pattern. Maybe that looked kind of familiar. So why is that important? Why have we been doing these box problems since, I don't know, the first couple of weeks of school? Well, we are going to flip the page to page 362. And here is why. I'm actually going to add a problem down here on the bottom really quick. Ready? Actually, you know what? Better yet. We're not going to do 362. I want you to flip to page 364 because I actually already added a problem on there. We're going to do a little quick review, and then we'll talk about why those box problems are important. So, multiplying. I know, first, how do I know I am multiplying? I know I am multiplying because there's no plus sign, no minus sign in between these two binomials. Binomials because there's 2 terms in each parenthesis. So I know I'm multiplying because I would have to see a symbol if I was doing any other operation. So we said in order to multiply, you could do that distribution or FOIL method that I talked about in a previous video, but the box method is probably the most efficient, and it's also the best way to keep you organized. So let's review, how do you set up your box? Well, my first parenthesis can go on the side or the top, up to you. I'm going to put mine on my top, x plus 3, and I'm going to separate my terms at my plus sign with a line. One column for x, one column for 3. My other parenthesis is going to go down the side, x plus 2, and I'm going to separate my two terms, my x and my 2, with a line. I am now going to multiply to fill in my box, kind of like those Punnett squares in biology. So x times x is x squared. X times 3 is 3x. X times 2 is 2x, and 2 times 3 is 6. The box is great for organization, but we never answer in a box. We're going to take all that out of the box. So we have x squared plus 3x plus 2x plus 6. We are going to look for some like terms, things we can actually add together since we see those plus signs. And I see 3x and 2x. They both have an x, so that makes them like terms. So if I have 3x's here and 2 here, we have 5x's. And I'm going to bring down the x squared and the 6 because they didn't have like terms. We just multiplied our two binomials. So again, how is this, those box problems where we're multiplying to the number on the top, adding to the number on the bottom, related? Well, what if I gave you, and I did, this x squared plus 5x plus 6, and I said work backwards. Figure out for me what two parentheses, what two binomials we multiplied to get x squared plus 5x plus 6. What if I ask you to undo this multiplication? I give you the answer, and I want you to work backwards to get to the problem. That process of working backwards to figure out what did I multiply, the process of what did I multiply. Now, you'd like to say it's division because the opposite of multiplication is division, but you can think of this as a very special division because this box is a very special multiplication. We call undoing it, answering the question, what did I multiply? We call it factoring. And I cannot stress enough how much this whole process of factoring is going to follow you to every other math class you will take in your life. Factoring will keep following you. So how does this factoring work? Okay, here we go. How does this factoring work? Well, I'm actually going to run through this example here in number 1, and then I'm going to compare it back to what you see up here. So in number 1, we have x squared plus 10x plus 21. So that 21, if you want to think about these special box problems, that 21 is what you need to multiply to. That 21, if you have this special box, that 21 goes on the top. That 10 is what we need to add to. It's what goes on the bottom. I need two numbers that multiply to 21 and add to 10. Now you will notice here, it says factor pairs of 21x squared. Factor pairs means I need two numbers that multiply to 21x, and factor pairs with a sum means I need to add to 10x. So where did that x squared and the x come from? Well, the 10x makes sense because the 10 has an x after it. So where did the x squared on the 21 come from? Well, we need to introduce that first term. So we like to do like a rainbow arc or a jump over, and 21 times x squared is 21x squared. I need two numbers that multiply to 21x squared and add to 10x. Now you can work it out in this format just like we did at the beginning, or very similar to what we did at the beginning. You could also work this out in this kind of listing format that I'm doing right here. Let me see if I can adjust my camera for you. So here we go. I'm going to not worry about the x squared yet. Things that multiply to 21. Well, I got 1 and 21. Well, if I want an x squared at the end, we know x times x would give me x squared. So 1 times 21 is 21. X times x is x squared. So really, all I have to do is put an x after each number. If I focus on the 21 and what multiplies to 21, once I pick those numbers, I just add an x at the end. So what about 2? 2 times a decimal would give me 21. But 3 times 7 would give me 21. I'm going to place an x at the end. 4 would be times a decimal to get 21. 5 times a decimal would give me 21. 6 times a decimal would give me 21. 7's already on my list. So I figured out what multiplies to give me 21x squared. I need to figure out what adds, though, to give me 10x. Well, I know that has to be the 3x and the 7x. If I add or combine like terms, that's what's going to give me a 10. This backwards, what multiplies, what adds, is going to help me undo this multiplication. So here's what we do. We then take those two numbers, once we chose what add, and we put them on the diagonal in our box. The numbers that add go to the diagonal on my box. Let's see if I can make myself a note here. The numbers that add, here we go. I'm trying to find a correct pen. These are the numbers that add. And my other two boxes are going to be my very first term, my squared term, or my a term. That's where we'd get the a from in the quadratic formula. And my last one would be my constant term, or my c term. So this is my a term, and this is my c term. A term and c term. So now we're going to work backwards. Now that we have the box filled in, we're going to work backwards and see what did they have in common. So if I look here, 2x and x squared. I'm not going to say they have a 2 in common because this is a number in front and this is an exponent, but they have an x in common, so there's an x on top. What do 3x and x squared have in common? An x, so there's an x outside. What do 6 and 2x have in common? I can say 2 because I can divide both 2 and 6 by 2. And what do 6 and 3x have in common? 3. So I'm going to do something similar here. What do 7x and x squared have in common? X. I'm going to work to the left. What do 21 and 3x have in common? Well, 21 and 3x, they don't have any x's in common, but 21 and 3 are both divisible by 3. Similarly, if I go this way, 3x and x squared have an x in common. 7x and 21 don't have an x in common. 21 doesn't have one, but 21 and 7 are both divisible by 7. Notice we just put on the outside of our box what they have in common. We call that a greatest common factor, or GCF. I'm sure you've heard that terminology before. We have what they have in common. And notice what's on the outside of the box. What's on the outside of the box is what we multiply, which means our factors, the things that multiplied to give me this guy, this big trinomial, must have been an x plus 7 because that's on the top of my box, and an x plus 3 because that's down the side of my box. What we just did is called factoring. It's answering the question, what did I multiply in order to get this answer? What did I multiply right here in order to get this answer? And doing that X box problem that we've done for so long is really the key. So I'm going to run through a couple more examples, and then I'm going to let you try on your own. So our next one, we need factor pairs of, well, this is going to be that arcing one, 33x squared. And we need them to add to 14x. We need them to add to our b term. So don't let the x mess with you. Don't let the x's mess with you at all. We need to multiply to 33x squared. We need to add to 14. So what multiplies to 33? Well, 1 times 33. And in order to get that x squared, I'm just going to add an x to the end. 2, not going to go in. 33 is not even. 3 times 11 gives me 33. I'm going to put an x at the end to get that x squared. 4, 5, 6, 7, 8, 9, 10. None of them are going to work. You can try them. I'm going to tell you none of them are going to work. So this is what I'm working with. From those pairs, I need ones that add to 14x. What's going to add to 14? Well, 1 plus 33 is 34, but 3x plus 11x would give me the 14x. So now that I've chosen those numbers, they're going to go on the diagonal of my box. And these ones that I put the rainbow over, going to go in the top left and bottom right. And I'm going to work backwards to figure out what did I multiply to get this. I'm doing a process, like I said, called factoring. So let's see. I'm going to work to the left first. X squared and 11x have no numbers in common because x squared has none, but they have an x in common. 3x and 33 don't have x's in common because the 33 doesn't have one, but 33 and 3 are both divisible by 3. Going up now. X squared and 3x have an x in common, no numbers because x squared doesn't have any. 11x and 33, well, 33 and 11, both divisible by 11. Now that I know what's on the outside, I know that x plus 11, because it's on the top, times x plus 3 must have multiplied to give me this trinomial that I started with. I am going to run through the rest of the odd examples, 5, 7, and 9. If you're like, dude, Mrs. P, this is easy, then do me a favor. Pause it right now. Pick one of the evens to try. Some of the evens are going to be part of your homework. So if you're feeling confident, pause, try an even number on your own. If you're successful, try another even number. If you need some more practice, start the video back right here. We're going to go through this one, otherwise 5, 7, and 9 together. So notice the prompts are starting to eliminate. Look back up to 1, 3 to see what those prompts are. So first thing, I need to know what multiplies to give me, there's my rainbow, 42x squared. I need factor pairs of 42x squared. So I'll list those out first. 1 times 42 gives me 42. I'm going to throw in the x's for the x squared. 2, I'm going to use the x's, times 21 gives me 42. 3 times 14. 4 doesn't work. 5 doesn't work. But 6 times 7 gives me 42. And 7 is the next number already there. So I already did this factor pairs part, this time of 42x squared. But I need a factor pair with a sum of my middle term. So I need to add to 13x. So going through here, 1 plus 42, not 13. 2 plus 21 is 23. 3x plus 14x is 17x. Oh, 6x plus 7x is going to give me the 13x. So I'm going to put that in here on the diagonal. Once I have the pair that adds, they go on the diagonal. My rainbow terms, my A term, x squared, and my C term, 42, go here. And now we're going to work backwards to figure out what did they have in common. So going to the left, x squared and 7x, well, they have an x in common. 42 and 6, no, they don't have an x in common because 42 doesn't have one, but they're both divisible by 6. Notice what's on the side. X plus 6 must have been half of what multiplied to give me this trinomial. So now I'm going to work up. X squared and 6x have an x in common. 7x and 42 are both divisible by 7. So I must have multiplied x plus 6 and x plus 7 in order to get this trinomial I started with. In other words, we just factored our trinomial. 2 more to go. I'm going to look over on page 365. The only difference on this page is we're going to start throwing in some negatives. And again, if you're like, I got this, try some of the evens. Come back to this video if you need it. So the prompts are back in here. Well, this time we want factor pairs of negative 28x squared. I'm not going to worry about the negative for right now. Just like these problems, we can worry about the negative once I have my list. So things that multiply to 28, x squared. 1x times 28x. 2x times 14x. 3, nope, that would be a decimal. 4x times 7x. 5 and 6, not going to work. Okay. I need a pair. We did our multiplication. I need a pair that adds to this middle term, our b term, 3x. Now, looking at what looks like they're 3 apart, that is certainly our 4x and our 7x. The question is, though, how do I get them to multiply to a negative? I need one of these to be negative, but I need to make sure that if one of them is negative, they still add to 3. Well, the one that's going to be negative is going to be our 4x. Negative 4x plus 7x is 3x. And if I go back to multiplying, negative 4x times 7x is negative 28x squared. Now that I've chosen those again go on my diagonal. Don't forget that negative on the 4x. My rainbow terms right here, my A term and my C term. Now notice that 28 is negative. That's going to be really, really important. Those go in my box. Okay, what do they have in common? In order for me to answer what did I multiply to get this guy, I need to know what do these guys have in common. So working from the top to the left, x squared and 7x have x in common. Notice it's kind of been a pattern through everything. Now notice these bottom two terms, they're both negative. So we can say, hey, they have that in common. Negative 4x and negative 28. They have a negative in common, so ignore the negative at this point. 4 and 28 are both divisible by 4. So we know one of the factors of this guy is going to have to be x minus 4. And now working the other way, x squared, negative 4x. They have an x in common. Notice they're not both negative, so I'm not going to use a negative. 7 and 28, they're not both negative, so I'm not going to put a negative up there, but 7 and 28 are both divisible by 7. So what multiplied to give me x squared plus 3x minus 28? X minus 4 times x plus 7. One more example. Here goes. Notice the prompts are gone, so I'm going to use these prompts to help me. I need a pair of numbers that multiplies, notice the negative, to negative 24x squared. So here we go. 1x times 24x, I'll deal with the negative later. 2x and 12x. 3x and 8x. 4x and 6x. 5 would be a decimal. I need a pair, again, pay attention to the negative, that adds to negative 5x. So just scanning through what looks like they're about 5 apart. Well, to me, that's the 3x and the 8x. But again, I need to throw in a negative, so we multiply to a negative and we add to a negative. I'm going to focus on the adding. If I made this a negative 3, negative 3x plus 8x, well, that'd be positive 5x, which means the 8 needs to be negative. 3x plus negative 8x. Yep, that adds to give me negative 5x. So now that I chose those two, again, those go on the diagonal, 3x, negative 8x. My A term of x squared on the top left, my C term of negative 24 on the bottom, and now I'm going to look for what do they have in common. X squared, negative 8x have an x in common. 3x and negative 24, again, they're not both negative, so I'm not writing a negative, but 3 and 24 are both divisible by 3. Going bottom up now, x squared and 3x have an x in common. And, oh, look, they're both negative, so I'm going to throw a negative in here. 8 and 24 are both divisible by 8. So what multiplied to give me x squared minus 5x minus 24? Well, that must have been x and a positive 3, so x plus 3, and x minus 8 must have multiplied. This process, again, of answering the question, what did I multiply in order to get a certain trinomial? Well, we call that factoring. And that whole thing is like those X problems we have been doing for a really long time with a couple extra steps. So if you need to, I want you to rewatch the video as you work through your homework. Otherwise, your homework is outlined on Canvas, what you need to do. Let's see if I can switch over to it. See, I don't have that page open. But your homework is right there listed on Canvas. Work through it. Send me an email if you have any questions, and I will see you next time. Keep in mind, we are almost to the end. You got this, kids.